Good afternoon, my YouTube viewers. It's Crystal here. I wanted to make another video for you. In this video, I'm going to be talking about theoretical probability, and I'm going to be going over 10 practice questions on theoretical probability to give you an idea how to calculate theoretical probability. Now, in my last video, I was talking about empirical probability, and that's where you use historical data to calculate probability. But theoretical probability is you're just guessing. You're just using theoretical concepts to calculate your probability. So we're going to calculate this theoretical probability in Excel, just like in my last video, we calculated empirical probability in Excel. So you get your Excel spreadsheet out, and you have your question. What is the probability of rolling a 4 on a fair 6-sided die? So you've got your number sides. A die is 6, and you've got your number of favorable outcomes is 1. So the theoretical probability is 1 over 6, which is B4 divided by B3, which is 16.6667%. So the next question we have is, a fair coin is flipped twice. What is the probability of getting 2 heads? So you're going to have 4 outcomes. You're going to have You're going to have 4 outcomes. It's going to be a head-head, a head-tail, a tail-tail, and a tail-head. And what you want, so you've got 4 outcomes. And what you want is you want 2 heads. So the number of desired outcomes is 1. And then, so you calculate the theoretical probability as 1 divided by 4 is 1/4. So you've got B12 divided by B11. So the next question we have is, what is the probability of drawing a heart from a deck of 52 cards? So you've got the number of cards is 52. The number of hearts is 13. And then the probability is 13 divided by 52 is 25%. So you've got B19 divided by B18. The next question we have is 2 fair-sided dice are rolled. What is the probability of getting a total of 7? So basically, you're going to have total outcomes is 6 times 6 because you've got 2 dice, 2 6 fair-sided dice. So that's going to be 6 times 6. So you're going to have 36 total outcomes. But the desired outcomes is going to be 1 plus, so 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7, 4 plus 3 is 7, 5 plus 2 is 7, and 6 plus 1 is 7. So you're going to have 6 desired outcomes. So the theoretical probability is going to be 6 divided by 36, which is 0.166667, or 16.67%, and that's going to be B26 divided by B25. The next question we have is, a bag contains 4 red, 5 blue, 6 green marbles. What is the probability of randomly pulling a blue marble out of the bag? So you calculate that by, you have 4 red, 5 blue, 6 green, and you have a total of 15. So you total up the red, blue, and the green. And the theoretical probability is blue divided by the total, which is B34 divided by B37, and so it's going to be 33%, or 33.33% really. The next question we have is, in a group of 23 people, what is the probability that at least 2 share a birthday? And you have to use the complement principle. So probability two people share the same birthday. So the complement principle is 1 minus 365 divided by 365 times 364 divided by 365 times 363 divided by 365 times 362 divided by 365 times 361 divided by 365 times 360 divided by 365 times 359 divided by 365 times 358 divided by 365 times 357 divided by 365 times 356 divided by 365, and then it goes on until you get to 343 divided by 365, and then you calculate that, and once you calculated that, that's 50%, 50.79%. So the next question we have is, a fair coin is flipped 5 times. What is the probability of getting at least 3 heads? So the probability of 3 heads and 5 coin flips is, you're going to use the combine function. So equals combine 5, 3 times 0.5 to the power of 3 times 0.5 to the power of 2 plus combine 5, 4 times 0.5 to the power of 4 times 0.5 to the power of 1 plus combine 5, 5 times 0.5 to the power of 5 times 0.5 to the power of 0. And then that gives you an outcome of 50% using the combine function. Now we have a question. What is the probability of drawing 4 of a kind in a 5-card poker hand? So you have number of cards in a deck is 52. Number of cards per suit is 13. Number of cards in a hand is 5. And there's 624 ways that you can get a 4 of a kind, because you have 13 times 48. And so you're going to subtract the 4 from the 52 to give you the 48. And then you got your total possible hands is combined B53 and then 5. And so it's going to be 2598960, and then your probability is going to be B57 divided by B58, and it's going to be like 0.24%. So it's a very low percentage. It's almost to 0. So the next question we have is, a factory produces 1,000 items, of which 10 are defective. If 2 items are randomly selected, what is the probability that both will be defective? So you've got 1,000 items produced, and you've got 10 defective items. And then you've got a scenario of the probability. So the first defective item, the probability is going to be 0.01. And the second defective item is B65 minus 1 divided by B64 minus 1, and it's going to be 0.009. And then the probability of both defective is going to be B69 times B70, and so it's going to be almost 0. It's going to be a really low number. It's going to be like 9 to the negative 5th. And the last question we have is, an urn contains 5 red, 3 white, and 2 blue balls. If you draw 2 balls, what is the probability that both are red, given that the first drawn ball is red? So you've got 5 red, 3 white, and 2 balls with a total of 10 balls. So you add the red, white, and blue together to get 10. The probability of the first ball being red is B76. That's red divided by B79, so that's 50%. And the probability of the second one being red is B76 minus 1 divided by B79 minus 1, and it's going to be 44%. So that's it. That's it for the 10 practice questions for theoretical probability. And some of the questions are more difficult than others, but you can experiment with them, and hopefully you will learn how to calculate theoretical probability using these practice questions. So thank you for watching my video. If you like my video, please like and subscribe. And I look forward to making more videos for you about data science scenarios in the future.